screencast is going to be about naming binary compounds, and I just want to make sure that we define binary compounds. So all the compounds that you worked with on the ion chart that you were working on are binary. That means they only have 2 elements. So you have 3 examples of that. So it doesn't matter what those 2 elements are, but anything that has 2 elements is binary. So you're really looking for how many capital letters there are. So if there's 2 capital letters, it's binary. You may remember from the flame test lab, you had compounds like barium nitrate. Okay, barium nitrate is not binary. So we'll see some examples of those coming up very, very shortly. So you probably already know the name of this guy. That's a very common compound, so that is sodium chloride. It's the formula for table salt. So that really illustrates what our rules are for naming binary compounds. Okay. Again, pretty simple. You're going to use the name of the cation, which is the positive ion, and the name of the anion, which is the negative ion. So for binary compounds, you have a single element. So nitrate has 2, but this is just Cl, just oxygen. So in a single element, the anion ending is dropped and the ending becomes IDE. So this would become sodium chloride. So sodium chlorine would tell us it's a mixture of the elements sodium and chlorine. The IDE ending tells us that they are chemically bonded. So this idea of IDE, I have a little weird saying for this one too. I'd rather be alone. So if it's just chlorine or just oxygen and not with another compound, it gets that IDE ending. Okay. We go to aluminum, we then have the name aluminum oxide. So if we just look at the basic nonmetals on the periodic table. I'm just going to go through some names here. So boron, you don't see a lot in ionic compounds, but boride, carbide, silicide. So some of these are going to sound really strange, but again, all of them are just getting the IDE ending. Nitride, phosphide, arsenide, oxide, sulfide, selenide, telluride, fluoride, chloride, bromide, iodide. Again, I've never seen a compound with astatine, but that'd be astatide. So these all get that IDE ending. It's just where that ending gets kind of chopped off is varies a little bit. And I'll give you a little forgiveness on, if you don't drop it exactly where it should be. But okay. Now you might have noticed I did not go through the name of this one. So if you can remember, there's something special about copper, and there's something special about many of the D block elements and the P block elements. So these are where we have our D block effect and our shielding effect. So many of these elements have more than one charge. So in order to specify which one it is, we have to include that charge in the name. So because the name of the charge of the cation can change, we have to start with the charge on the anion. So the nonmetals don't vary. So if we go to the periodic table for chlorine, we know that it is in the group 7A, so its charge is going to be -1. So I'm just going to work through this over here with this one. So chlorine is -1. So I'm going to write the whole formula. So then the second step is determine the total negative charge. So since I have 2 of these, 2 times -1 is going to be -2. So I use a 2-line system here. So this is the individual charge on the bottom. So that's every atom. So my individual atom charge, and this is the total charge. So compounds have to be neutral because of that law of conservation of matter. The number of electrons lost has to equal the number of electrons gained. So if chlorine is picking up a total of 2 electrons, copper has to be losing a total of 2. And then I look here for my subscript. Okay, there's nothing here, so that means there's 1. So I'm really looking at kind of algebraically. What number can I take times 1 to get plus 2? So this would be plus 2. So that's how I determine the total positive charge. Okay, so ultimately that would give me a charge of 2. So this would be copper 2 chloride. So again, the 2 tells us what the charge is. Okay. All right. Now, you'll see as we work our way down the sheet, there is a cupric chloride. So this is the Latin names. So this is called the stock system. So again, whatever that number is the charge. So if this would be copper 1, so if I go through that same process with the other charge of copper is copper 1, this compound's going to look like this. So I have 1 chlorine, so that would be -1. Okay, so there's no number to multiply, so this would be copper 1. So again, whatever this charge is, it's converted into a Roman numeral. So when this is plus 2, this is Roman numeral 2. Now, this both names, where do these Latin names come from? So if you go into blend, and you go under the information, you'll see there's a file called common ions. So this is a document that you're going to probably want to use a lot. So what it has here is a lot of charges. So these are the ones that you're going to be responsible for being able to navigate through. So we are doing copper plus 2. So since I look here at the plus 2 charge, I'm going to see that I have copper plus 2 and I have the name cupric. Okay. When I look for copper plus 1, you'll see that it is cuprous. So you're going to always have this ion document during tests and quizzes, so you don't need to memorize these. It is helpful if you do learn them, especially if you are considering taking the AP course. It's just one less thing you have to kind of deal with, and some of them you'll just learn from using them a lot. But so again, this chart is very important. You want to check here when you're given a list of metals to see what's happening with those. So the next example I have here is mercury. Okay, so if I go through my same type of system, I'm looking at sulfur. Sorry. So I'm looking for sulfur on the periodic table, so I find that sulfur is in group 6A, so that's going to be 6 minus 8 or -2, or if I follow my number line back, 0, -1, -2. So I know that sulfur is -2. There's no number, so that means my total is going to be -2. My compound has to be neutral, so my total positive has to be +2. So this time I do have a subscript here. So when I'm looking for my charge here, what number can I take times 2 to get +2? This would be +1. Okay. And if you look down through here, I've already named that. That's mercury 1 sulfide or Mercury Sulfide. So if you look where mercury is, it is not following really any of our patterns. It is sort of an odd creature here. Typically anything in the D block is +2, so the other charge we would see for mercury would be +2. So if I had +2, I wouldn't have that subscript of 2, and this would be my mercury 2 compound. And again, still be sulfide because sulfide doesn't change, or mercuric sulfide. So you might think that these ic endings mean 2 and OUS means 1. It's really higher and lower. So you're going to have a group of elements. So copper and mercury fall under the +1s and +2s. If you go back to your ion chart, you're going to see there's a group that are +2 and +3. So we have chromium, we have iron, we have cobalt. Okay, if it's Cr +2, it's going to be chromos. Cr +3 is chromic. So the IC really just means the higher charge, and the OUS is the lower charge. And then you're going to see a group that are +2 and +4. So those are your tin and lead. So tin +2 is stannous, and tin +4 is stannic. Okay, so we're going to have you practice a little bit with writing the names of these ions. You're going to go back to that same file that you did with the ion chart. So after that, you did this worksheet where you were writing formulas. So I want you to go back through. You can do it right on the same paper that you did this in. So just write them beside. If you don't have room to write them beside, if you just or underneath, just number the 1 to 10 and then just name them. Again, remember things like gallium have 2 charges, so you need a Roman numeral for those, and you should have 2 names. Not everything has a Latin name, so we don't have Gallic and Gallus, so that just sounds really strange. They all probably sound really strange, but so if you don't find it on that sheet, again, I'm always going to refer to that sheet as the green sheet. When I print it on paper, I usually do it on green paper. So you'll see that gallium is nowhere on this sheet. So there will be no second name for that, but you'll see iron, ferric, and ferrous is on this list, and you have the tin one, which I just went over, the stannous and stannic. Okay, so that'll give you some practice on naming.